Okay, we'll complete the last example. We only went through the first requirement, that was HB. Now we want to go through the other four requirements, phi A and YC. What does phi A means? The rotation at A. Okay, and what's the procedure of the virtual work? For any requirement, I have to draw the frame one more time without any loads, and then put a unit load in the same direction of the requirement. Here, it's required to calculate rotation at A, phi A, so I draw the frame one more time without any load, and then at point A, I will put a unit moment, because this is a rotation this time, so I'll put a unit moment, a moment of 1 ton-meter, and then I will draw the bending moment diagram that is called M2. Here, M node is the initial moment for the load, and any requirements, it will be M1, M2, M3, M4. So the numbering here for the moments does not mean anything. Not like the superposition, case node, case 1, case 2, no. Here the numbering of the moments is just a name for any requirements here. If there is 4 requirements, so you will have till M4, okay? And take care if you draw that M node. If there is something not correct, so all the requirements will be wrong, because every requirement you have to make the integration with M node. Okay, let's draw the moment of the case for phi A. First, I have to calculate the reactions, right? Is there any horizontal reaction here? No horizontal force, I mean horizontal forces. That means that XA here equals to 0. There is XA and YA. Let's take moment at A. So YB times 9 minus the moment 1 equals 0. So the reaction here will be 1 over 9 upwards. So the other reaction will be 1 over 9 downwards. Okay? In order to draw the bending moment, I have first to calculate the moments at the joints. How many joints here? I have 2 joints. Joint at E and joint at B. Let's start with the joint at E. Let's calculate the moment at E, which is the easiest part. EB or EA. EB is easier. Is there any force in the part EB that gives moment around E? No. So the moment here is 0. So the other part will be 0. Right? What about the joint at D? Here, it's F. So from DF, is there any moment at D from the part DF? Nothing. So the moment here is 0. What about the moment at D from the part DA? Is there any forces that give moment at D in the part DA? Yes. No horizontal reaction, but there is a moment 1 ton-meter. So the moment here will remain 1. So the third partner here in the joint, what will be the moment of the third partner, the moment at D from the third part DEB? It has to be equal to 1 in the opposite direction. Now I can draw the bending moment diagram. Let's start with EB. No moment at EB. Moment at B is 0. Moment at E is 0. For the DE, the moment at E is 0, and the moment at D is 1 downwards. For the cantilever DF, no moment at F and no moment at D. So no moment for the cantilever DF, the member DF. For the member DA, the moment at D is 1 to the right and and the moment at A is also 1 to the right. So there is a rectangle here. And it will be positive moment. So this is M2. So how do I calculate phi A? Phi A will be the integration between M node with M2 divided by EI dN. Okay? How will I integrate both diagrams? How many members do I have? I have only 4 members, FD, DE, EB, and DA. I do the integration for each member individually. For the member DF, there is a moment here in M node, but no moment here in M2. So DF is out, it's excluded. What other members will be excluded? EB. EB, no moment here at M node, and also no moment at M2. So EB is excluded. So I have only 2 members left. The member DE, the horizontal member DE, it has a moment here in M node, and it also has a moment here in M2. And the vertical member DA, it has a moment here which is a triangle, and also it has a moment here in M2 which is a rectangle. So let's remember how we do the integration of the figures. So first, 1 over EI is outside, and then open a big bracket. And then open a bracket for each member. So now I will start the vertical member DA. Let's start DA. Here there is a triangle which is a linear shape, and here is a rectangle which is also a linear shape. What is the rule for integrating a linear shape with another linear shape? It's L6 divided by 3 multiplied by the inertia factor, which is 2 for this member, and then the first value multiplied by the first value, so 18 multiplied by 1. What about the sign? Are they in the same direction or in opposite directions? The 18 is on the left and the 1 is on the right. So they are in opposite direction, so the sign will be negative. And then the second value multiplied by the second value, which is 0, multiplied by 1, 0. And then the first value multiplied by the second value, so it's 18 multiplied by 1 divided by 2. So the rule is the first value multiplied by the first value, the second multiplied by the second, and then the first multiplied by the second divided by 2, and then the second multiplied by the first divided by 2. What is the sign of the 18 and 1? Also negative, because they are also in the opposite direction. And the last value, the second, which is 0, multiplied by the first value, which is 1. So I'm done here. So the first member is done. Look at the brackets for the first member, this kind of brackets. And here, this is for the member called AB. And when you are initiating to start a new member, you have to add a sign which is plus, and then open a new bracket for the second member. The second member, which is DE, here there is a triangle, and then we subtracted a parabola, and there is a triangle. So how many integrations will they be in this member? First, I will integrate the triangle with the triangle, and then one more time the parabola with the triangle. So 2 parts here for this member. Let's start with the first part, the triangle with the triangle, so linear with linear, so the same rule, L, which is now 9 meters, divided by 3 multiplied by inertia factor, which is 4, and then the first value, which is 22, multiplied by 1. The 22 is upwards and the 1 is downwards, so they are on the opposite direction, so the sign will be negative. The second value multiplied by the second value, 0 times 0, 0. The first value, 22, multiplied by the second value, which is 0, divided by 2, will be 0. The second value here, multiplied by the first value there, divided by 2, which will also be 0. And then, one more time for the same member, the parabola with the triangle. What is the rule? What is the rule for the parabola with a linear diagram? The rule is the area of the parabola, but on the first we put only one sign. What will be the sign here? Positive or negative, depending on what? The parabola is subtracted, right? Any subtracted parabola, that means that it's downwards. Okay? What about YCG? What is the YCG? Go to the linear shape that you are integrating with the parabola. Calculate the value at the midpoint here. Here will be the average between 0 and 1, which is half. What about the direction of the YCG? It's downwards also. So downwards with the parabola which is subtracted, that means it's downwards. So it's same direction. So plus area of parabola. The rule is area of parabola. Area of parabola is 2 over 3 multiplied by the base, which is 9 meters, multiplied by the height of the parabola, which is the PL square over 8, the 20.25, multiplied by the YCG, which is half, divided by the inertia factor, which is 4. And now I can close the bracket of the second member. And I am also done, so I can also close the big bracket for the whole integration. The value here for phi A will be equal to negative 0.28. Negative 0.28. What does the positive or negative mean here? It means that when you decide to calculate any requirement, even it's a rotation or a vertical displacement or a horizontal displacement, you have to tell me what is the direction of the movement that happened. The last time when we calculated a horizontal displacement, you have to tell me what will be the direction of the horizontal displacement. Will it be to the right or to the left? If you are calculating a vertical displacement, you have to tell me if it's downwards or upwards. If you are calculating a rotation, you have to tell me to get the full mark if it's clockwise or anti-clockwise. So negative here means that I made a wrong assumption. What was the assumption? The assumption was that when I put the unit load, which is the 1 ton meter in red, I put it clockwise, and then the answer was negative. So that means that it's in the opposite direction. So the rotation that happened at A will be anti-clockwise. Okay. The last requirement here was YC. YC means the vertical displacement at C, and you have to take care from this intentionally. Why? When I ask about any displacement inside a uniform distributed load, again, when I ask about a displacement, any displacement, a vertical or a horizontal, I will not ask about rotation inside a distributed load, even the horizontal. Intentionally, I will ask about a vertical displacement inside a distributed load. What does that mean? When I ask you to calculate a displacement inside a distributed load. What does that mean? What do I have to do first? Can I do the member DE and put the concentration of the distributed load 2 times 918 as what I did when I drew M node? I did this 2 times 918 and then I calculated the reactions and then I drew the bending moment diagram, which is M node. But for this one, intentionally, this will be wrong. I am asking you to calculate a displacement inside a distributed load, so you have to draw the M node one more time, and you can't put the 18 here. You have to distribute it 2 times 4.5, 9, and 2 times 4.5, 9. Take care from this. When again, what is important point now? The important point when I ask you to calculate a displacement inside a distributed load, you can do this. I'm asking you to calculate vertical displacement at C, YC, so you have to distribute the distributed load, the concentration of the distributed load, it has to be split at point C, okay? So the big question is now, why didn't I do this from the beginning? Why didn't I do this from the beginning? 9 and 9. Why did I make 18 in the beginning to draw a node? And then now for M3, I will draw another moment, which is like M node modified. Let's name it like this, M node modified. Because if you do this from the beginning and you are integrating this shape with M1 and M2, this will be so complicated to understand. What do I mean? Let's now draw the M node modified. Now I have to draw just the moment for the horizontal member that has a problem. How will I draw it again? So this can't be one curve. Now I have 2 distributed nodes, DC and CE. So here in the M node modified, there will be 2 curves. Okay? So this is called M node modified. So here the moment will be 22, nothing will change. Here the moment will be 0, nothing will change. What will I change? You have to only calculate the moment at C. Okay? Let's calculate the moment at C. Let's say right, but I have to know the reactions. Can anyone tell me what was the reactions last time? Reactions for case nodes. Yeah, this was 6.56. YD was 6.56. And YA was 15.44, and XA was equal to 3, and there was 3 here. Okay. So I now want to calculate the MC right. MC right will be 6.56 multiplied by 4.5 minus 9 multiplied by 2.25. So this is 4.5. C is in the midpoint, and 9 is in the middle of the 4.5, so it will be 2.25. So M be right here will be equal to, I think, 9.25, right?
9.27.
9.27. 9.27. And it will be the 6.56 times 4.5 is the biggest, so the tail will be downward. So the moment here is 9.27 downwards, and then how do I draw the bending moment? These are two different uniform distributed load, and in the uniform distributed load, I just calculate the moment at the beginning and the moment at the end, and then join and do the PL square over 8. So I will join this like this, and then PL square over 8, and then I will join this and do the PL square over 8. But now the L is only 4.5. So 2, 4.5 square divided by 8, and here 2, 4.5 square divided by 8, which will be equal to 5.06. What's the difference between the M node modified and the M node? Same shape. It's the same shape. But I came in the middle and split the one curve into two curves. That's what I did. Okay? And why did I do that? Because I can't calculate the moment at C with the 18. Because now I have to deal with the one uniform distributed load in the member that was called DE. I have to deal with it as two distributed load now, DC and CE. Okay? I think the answer for the question, why didn't I do that from the beginning, is clear now. Here, how many diagrams was I having in the member DE? It was a triangle subtracted or subtracting a parabola from it, right? So just two shapes, two diagrams. And in the M node modified, how many shapes do I have? On the left hand side, I have a trapezium. Yes, this is called the trapezium. This is called, or we deal with it like a trapezium. We deal with it like a trapezium, but only the value is downward instead of upward. So this one is a trapezium, subtracting a parabola, and then on the right hand side, a triangle subtracting a parabola. Why I do this complicated shape, which was only two shapes, and then now there are four in the case of M1 and M2. I don't need that. I just need that, or I just need to do the M node modified only in this requirement in YC. Okay? Let's draw the moment of M3 YC. So I have to put a unit load at point C in the direction of Y. So like this. Right? What will be the reactions? Here it's A, B, C, D, E, F. So the reaction here will be half, and here will be half. And XA will be equal to 0. Let's calculate the moment at the joints. Let's start with joint E. The moment at E from the part EB, nothing, 0. So the other side will be 0. What about the joint at D? The joint at D, from DF, it's 0. And from DA, also 0, nothing. So the third part will be equal to 0. Oh, no moment at the joints? No moment at the joints. But we have now to calculate the moment at point C. Are we supposed to calculate only the moment at the joints? No. We have to calculate the moment at any point having a concentrated load. So I have to calculate the moment at point C. What is the moment at the point C? It's half multiplied by 4.5, which is 2.25, and this will be the moment M3. In the shapes, when we are integrating a linear shape with a linear shape, do we get a shape like this that have zero value at the beginning and at the end? No. The shapes was like a perpendicular shape for the triangle. So that's why here I have to split this as a triangle and this part as an other triangle. So that is the second reason why did I do this in the M node. So I have two reasons to draw a node modified. Two reasons now. The first reason that when I draw the moment M3, I found it split at point C like this. The second reason, so I have to split this in order to integrate the two diagrams with each other. The second reason that when I need anything, any displacement inside the distributed load, I have to deal with the distributed load as two splitted distributed load. So that's why I drew M node modifier. Now, what will be YC? So YC is the integration of M node modified with M3 divided by EI dN. How many integrations I have now? How many integrations? For the part DC, here it's a triangle, which is a linear shape, and here will be a trapezium with a parabola subtracted from it. And the right-hand side, CE, here will be triangle and a parabola with a triangle. So how many integrations? For DC, I have two integrations, trapezium with triangle and a parabola with triangle. And for the part CE, I have also two integrations, a triangle with a triangle and a parabola with a triangle. Okay? We will not do it. We are fed up now with the integrations. So that's it. I can give you the final answer of YC just to double check when you solve it. So YC here will be equal to, okay, this is an arch frame, a simple arch frame. So we have first to remember how we draw bending moment diagram for the arch from structure 1. Okay, so you can go to the video of structure 1. I will say now a brief, but you have to go to the videos of the arch frame in structure 1. Okay, so let's start and see what will the arch differ. Okay, first let's calculate the reactions. Here I have a distributed load from E to F. So the concentration will be 2 times 12, which is 24 in the middle. The reactions here I have XA and YA. And here I have YD. So regardless what is required here, I calculate the reactions and draw bending moment, and then I will see what's required. Okay. XA is 2 ton to the right, the opposite direction for the 2 ton at point B. Okay. Let's take sigma moment at A to calculate YD. So 24 times 6, and then 4 times 15, and then 2 times 6, and YB times 12. YB will be equal to 16 ton. Sigma Y, 24 and 4, 28. YB is 16, so YA will be equal to 12. Okay. Let's calculate the moment at the joints. How many joints do I have now? I have 2 joints, joint at E and joint at F. What about the moment at the joint at E? I think from EA is easier. So it's 2 times 6, 12. So the other side has to be equal to 12 as well. right? What about a joint at F? I think from FD, it's easy. 4 times 3 is also 12. And FB, is there any moment at F from the part FB? Nothing, so the moment at F from FB is 0. So the third part, the moment has to be equal to 12. To be the sigma moment at the joint, it has to be equal to 0. I can now draw the bending moment. Let's start with EA, the member EA. The moment at A is 0. The moment at E is 12 outside and no distributed load. So the moment here will be equal to, or will be a straight line. Okay? The moment at FD, at D is 0, at F is 12, no distributed load, so the moment will be a straight line as well. The first question no one asked. When I draw bending moment for the arch member, where is the arch member here? EF, right? When we draw moment for the arch EF, I have to draw the moment on the horizontal projection. So I draw the EF as a horizontal line. Okay? This is how we deal with the arch when drawing the bending moment diagram. We draw it on the horizontal projection. Okay, for FB, the moment at F equals 0 and the moment at B also equals to 0. What about the last member, which is the arch, the EF? The moment at E is 12 upwards, and the moment at F is also 12 upwards, so it will be the same here, right? And then there's a distributed load, so we have to join the moment at the beginning of the distributed load with the moment at the end of the distributed load, and then we do PL square over 8? No, it's not PL square over 8. There is a rule when it comes with an arch. The rule is PL square over 8, right? But this is the loads effect. This is called the loads effect. And then there is an arch effect. Structure 1, all this is structure 1. Arch effect. What is the arch effect? It's plus or minus x times f. So now instead of PL square over 8, it is now for the arch PL square over 8 plus or minus x squared. So that means the arch can be a parabola in the bending moment diagram without any loads, without any distributed load, because the effect is not only from the loads, there is an effect for the arch itself. So don't be surprised if there is not any distributed load on the arch, and you also in the bending moment draw a second degree parabola. Okay? So that means in the cases of M2, M3, and M4 of the requirements, I can see a curve, a second degree parabola in one of them or in all of them. We didn't see this before. Why? Because in the moments of the requirements, we usually draw the frame at one more time without any loads. So it's impossible to get a second degree parabola in a regular frame, which is not arch, I mean. Okay? But here in the arch frame, don't get surprised that in the case of the unit load, you can get a second degree parabola in the bending moment diagram. So the question that will rise now, what will be the question now before I continue? What's the question? How will I do the integration of a parabola with a parabola? The two rules I got so far, a linear with a parabola and a linear with linear. So I have to learn now how will I do the integration of a parabola with another parabola. Okay? So again, let's continue. So the value here is PL square over 8 plus or minus x of f. What is x? What is f? And when it is positive and when will it have a negative sign. Okay? I know the PL square over 8. So now I need to know who are these. Let's start with the x. The x is a summation of any horizontal loads either from the right hand side of the arch or the left hand side of the arch. So what is the, let's get a section here. What is the horizontal, what is the summation of the horizontal forces here? It's only 2, right? So the summation here is 2. What is the 2 doing? Is it compression or tension? I think it is doing a compression. So a compression is negative and tension is positive. So what about F? F is the height of the arch. F is the height of the arch, and take care from this definition. To get F, you have to join a line from the beginning of the arch till the end of the arch. The beginning of the arch till the end of the arch. F is the vertical distance in the middle. So what is F here? 3 meters, right? So F here is 3. What about PL square over 8? The regular one P is 2. L is 12 squared divided by 8. So what will be the answer? And take care from the sign of the answer. Take care from the sign. Will it be positive or negative? So can anyone calculate it for us? I think it will be 36, right? Minus 6, which is 30. Positive 30, right? What is the meaning of positive when this value, when this total value is positive and when this total value is negative? What's the difference? When it is positive, that means the regular shape for the parabola, which is downwards, right? So that means that this is a downward parabola and this is the high. This is the circle, right? When this is negative, that means that the parabola will be upwards. So take care from the sign here. Okay? Okay, so this is a node. Here is a negative movement and here is the positive. Let's go to the first required displacement. It's HB. So horizontal displacement at point B. Okay, so I have to draw the arch frame one more time, but without any loads. I will put a unit load, only a unit load, in the direction of the required movement. Here, the required movement is a horizontal movement at B. So at B, I will put a horizontal load of 1 ton. Okay? And then I will draw bending moment again, which will be called M1. But first, I have to calculate the reactions, right? Let's calculate the reaction. So here, XA will be equal to 1 in the opposite direction. What about YA and YB? Let's get a moment at A. So it will be equal to YB times 12, and then 1 times the difference between 6 and 3, which is 3. So 3 over 12. So this will be downwards. 3 over 12, which is quarter. And this will be upwards, also quarter. Okay, let's calculate the moment at the joints. Okay, the joint F, the moment from FD, nothing. From down, oh, it will be 1 times 3, which is equal to 3. So the third side has to be 3 as well. What about the joint at E? E from down will be 1 times 6, 6. So the second direction has to be also 6 in the opposite direction. Okay, let's do the bending moment. Let's start with the member EA. The moment at A equals to 0. The moment at E equals to 6. And then straight line. No distributed loads. Right? The member FD, the horizontal member, the cantilever FD, 0 and 0, so no moment. The vertical member FB, the moment at B is 0, the moment at F is 3 in this direction. What about the arch? Please take care. The arch EF, the moment at E is 6 upward. The moment at F is 3 upward. Please join a dotted line and wait for the parabola. Parabola, no distributed load. Yes, I know there is no distributed load, but there is the effect of the arch. Okay? So what will be the value? PL square over A plus or minus X times F. No PL square over A. There isn't any distributed loads here, right? What about X times F and the sign? X is the summation of the horizontal forces either from the left of the arch or from the right of the arch. From the left of the arch, what is the summation of the horizontal forces? It's only 1. What is the 1 doing? Is it compression or tension? It's compression. So negative 1 multiplied by F, which is 3. So it is negative 3. What does the negative mean? It means the parabola will be upwards. Here the value was positive, so the parabola was downwards. Okay? So this is M1. What about the value of HB? HB will be equals to the integration of M node with M1 over DI. Let's do the integration, but without doing the workout, just the diagrams. How many members will be included in the integration? Here I have 4 members, AE, EF, FB, and FD. For FB, no moment here, so it will be excluded. For FD, no moment here in M1, so it will be excluded. So I have only 2 members that will be included in the integration. The vertical member AE, which will be a triangle with a triangle, so linear with linear, and it's easy. Let's concentrate now on the other member, which is EF. How many integrations do I have? First, I have here a rectangle, which is a linear shape, with a subtracted parabola. And here I have a trapezium with an added parabola, right? When I start with the rectangle, I have to take or integrate the rectangle once with the trapezium and once with the parabola. And then I will get the parabola and integrate it once with the trapezium and once with the parabola. Okay? So what's weird here in this integration? It will be 4 integrations, right? The rectangle with both of them, and then the parabola with both of them. So now I need a rule for a parabola with a parabola, right? So the integration, when I'm integrating a parabola with another parabola, with the length of a member is L and inertia factor which is X, and this is having a value of A and this is having a value of B, so the integration will be equal to 8 over 15 A times B times L divided by X. So A for the first parabola, which here will be 30, and B for the second parabola, which will be equal to 3 without any signs. 30 times 3, okay? Times L, which is 12, divided by X, the inertia factor. We didn't state any inertia factor for the R, so it's 1. And then here will be a sign. There is a sign here. There is a sign here. What is the sign? Always when we started the integration, the sign is positive if I'm integrating or multiplying two values in the same direction, and it is negative when the two values are on the opposite direction, right? Here it will be depending on the A and the B. Are they in the same direction or on the opposite direction? In my case, the 30 is downwards, right? The first parabola is downwards, but the second parabola is upwards, so the sign will be negative. So don't take the effect of the sign twice. Don't say 30 times negative 3 and then a negative for the opposite direction. No. The negative sign you will take the effect of the sign one time in the beginning. And when you multiply A times B, 30 times 3 without any signs, you only put one sign for the whole value. The 8 over 15, A times B times L divided by